Hi, Trigoners. So right now we're going to do notes for day 2 of sequences. And we're going to start by looking at some definitions. So first of all, a sequence is an ordered list of numbers or objects. And an arithmetic sequence is, for example, an arithmetic sequence would have numbers that you would add the same or subtract the same number to generate the next term. So for example, an arithmetic sequence might be something like 1, 3, 5, 7, 9. These 3 dots mean that it just keeps going. So this would be an infinite arithmetic sequence. Notice that the common difference can be found by subtracting 3 minus 1, and that is 2. So we say the common difference D is 2. Now let's say, for example, over here it went 9 and then it said something like 15 or something. Notice now this is not arithmetic anymore because that does not follow the pattern. So would have to have the same number that you're adding or subtracting each time. So we would say a sequence in which each term is obtained by adding or subtracting the same number, which is the common difference. Now, let's say we had a geometric sequence. So an example of a geometric sequence might be something like how about 2, 6, 18, 54. Notice I didn't put the 3 dots, so this one is a finite. This one stops, geometric sequence. Notice that if I do 6 divided by 2, I get 3. So we have a common ratio, R, which is the number that you're multiplying by to generate the next term of the sequence. So a geometric sequence is a sequence in which each term is obtained by multiplying the same number, which is the common ratio R to the previous term. So if I want to know, let's talk about notation now. A sub n, that means that is the nth term of the sequence. Now, as far as notation goes, let's say I have a sub 1, that's the first term, then a sub 2, that's the second term, then a sub 3, that's the third term. Now, way out here, I might have the nth term. The term before it, the term preceding the nth term, is the a sub n minus 1. The term right after it, a sub n plus 1. You could keep going. A sub n plus 2 would be after that, etc. Before the a sub n minus 1 term, you would have the a sub n minus 2 term. So that's what the notation means. Let's go ahead and experiment a little bit too with some sequences. So this first one, it says a sub n equals 3 times 2 to the n. So if I wanted the first 4 terms, first we would say let's let n be 1. So the first term is 6. If I want the second term, let's let n be 2. So the second term is 12. Let's let n be 3. So the third term is 24. And if we let n be 4, the fourth term, 16 times 3, that's 48. So we could find the first 4 terms. Okay, so let's think about what type of sequence this is. So our numbers were 6, 12, 24, 48. Notice that this one is geometric. And this is actually an explicit definition. So let's see, I'm going to erase these. We have a little more space. This is an explicit definition. Because it defines each term in the sequence. So later we're actually going to talk about something called a recursive definition. And a recursive would be, I could describe any term in the sequence by the term preceding it, right? Because a sub n minus 1 is the term before a sub n, and you would multiply by 2 to generate the next term in the sequence, but I would have to give you the first term, And again, this is for values of n greater than 1 because we don't talk about the 0th term or the -3 term. These are all integers, and we start with the first term. Okay, so that's actually just a little peek into what's going on. Let's just keep going with these examples. So for number 2, over here, notice that we have another formula. And we're going to go ahead and take a look at that one. Make this a little bit bigger. There we go. All right, so for the second one, we want to know the first 4 terms. So again, we could let n be 1. So the first term is 3 times 1 minus 2 plus 4. So the first term is 1. If I let n be 2, the second term is 3 times 2 minus 2 plus 4, which is 4. If I want to find the third term, that's 3 times 3 minus 2 plus 4, which is 7. And to find the fourth term, that's 3 times 4 minus 2 plus 4, which is 10. So my sequence is 1, 4, 7, 10. And we notice that that one's arithmetic with a common difference, D, of 3. Okay, what about this next example, number 3? If I want to find each term, I would first let n be 1. I would then let n be 2 to find the second term. I would then let n be 3. And I would then let n be 4. So here's my sequence. Okay, for this next example, this is going to be kind of interesting. We have a -1 to the n plus 1 power. Watch what happens. If I want to find the first term, notice it's -1 squared, which is a negative to an even power, so that's going to be positive. But if I let n be 2, -1 to the third power, 3 is an odd number, so I end up with a negative number. So let's continue on, and we find the third term and the fourth term. And when you look at the sequence of numbers, notice that the negatives are alternating, right? So this one couldn't be arithmetic because you're not adding or subtracting the same number. But notice this one does have an alternating negative sign. Very interesting. Okay, let's go ahead and look at 3b. It says find the 100th term in number 3. Okay, well, you could let n be 100. And for 4b, it says, how could you change number 4 so that the first term was negative, the second was positive, so it would still alternate, but instead of going positive, negative, it would go negative, positive. Well, notice if you took the -1 and if you took it to the nth power, now if n is 1, you would have a -1. If n is 2, you would have a positive 1. Okay, so if you turn to the next page, now we're going to look at just arithmetic sequences for a while. So if a sequence happens to be arithmetic, in other words, that the terms have a common difference, that means you're adding or subtracting the same term to the previous term to generate the next term. So let's just do one of these examples. How about if we do number 1? So notice 4 minus 1 and 7 minus 4 and 10 minus 7, they're all 3. So your common difference is 3. Okay, so go ahead and pause the video and find the common difference for 2 and 3. Okay, so now notice for number 2, the common difference is -4, and for number 3, 1/2 minus 1/4, 3/4 minus 1/2, 1 minus 3/4, they all have the same common difference of positive 1/4. So now that we found the common differences, let's talk about a general formula. So if we want a general or explicit formula, notice that first we have the first term, and then we have the second term, which is the first term plus the common difference. And the third term is the first term plus the common difference again. So notice this is a sub 1 plus 2 common differences. This is a sub 1 plus the common difference times 3, etc. So that's why we have, this is our formula for the nth term of an arithmetic sequence. Okay, so if we wanted to go back now and go ahead and figure out what would a rule be to describe this for the first one, you could say, well, a sub n is a sub 1 plus d times n minus 1. So you end up with the first term plus the common difference times n minus 1. So this is a rule that will give you any term in the sequence. And again, it's called explicit because if I wanted the 100th term, for example, I would just put 100 in for n. Go ahead and pause the video and go ahead and find explicit formulas for number 2. Okay, so hopefully you got number 2 as a sub n equals 12 minus 4n. Okay, so why don't we go down now to that last question, number 6, and it says, given an arithmetic sequence with the first term given and the common difference, can you find a formula? Well, you could, because we know the formula is a sub n equals a sub 1 plus d times n minus 1. So the nth term is 5 minus 3 times the quantity n minus 1. So you would say a sub n equals 5 minus 3n plus 3, which is 8 minus 3n. Now, if for some reason you wanted to find the 10th term, all you do is put 10 in there. Oops. And you end up with negative 22. Okay, so let's go ahead and look at geometric sequences now. Geometric sequences, again, a sequence in which each term is obtained by multiplying the same common ratio to the previous term to generate more terms. So go ahead and pause the video for a second to find the common ratio for 8 and 9. Okay, so welcome back. Hopefully you said 12 divided by 4, 36 divided by 12, 108 divided by 36, they're all 3. And in number 9, 12 divided by 24, 6 divided by 12, etc., they're all 1/2. So we want to find the general form, or the general term, an explicit formula. So if you think about it, we have the first term, then we have the second term, which is just the first term times r, and the third term is the first term times r again, and the fourth term is the first term times r times r times r again. So notice that an explicit formula would be the first term times r to the n minus 1. So if we go back now, we could find an explicit formula for number 8. It would be the nth term is the first term times the common ratio r to the n minus 1. Pause the video for a minute and go ahead and find the explicit formula for number 9. Okay, welcome back. So an explicit formula would be 24 times 1/2 to the n minus 1. Okay, so let's go ahead and take a look now at the last question. It says, given a geometric sequence with the first term given and common ratio, can you write an arithmetic sequence, a formula? Well, we sure could. Here's our formula. So if the first term is 4 and the common ratio is 3, there's our explicit formula. And now for some reason, if we wanted the 14th term, that just says, let's let n equal 14. And you end up with, you have to use a calculator for that one. That's a big number. There you go. Have a great day, everybody.